In this video, we're going to learn how to calculate the one-way analysis of variance, or ANOVA, by hand. Now, this is admittedly a very laborious process. There are lots of steps to follow. There's lots of formulas to learn, but I'm going to walk you through all of that. We're going to go over all the formulas you need, and I'm going to show you some simple steps you can follow, which will take a little bit of work to master, but you can follow these steps to make sure you get the right answer every single time when you're calculating the one-way analysis of variance. To start, let's take a look at the test statistic that we're after. This is the F ratio, just in generic terms here. This is our test statistic. So the z-test has the z-test statistic, the t-test has the t-test statistic, but the analyses of variance have the F ratios, or the F-test statistic. And this is called a ratio because look at the generic formula here. It's a variance divided by a variance. It's an analysis of variances, and specifically it's a ratio of two different variances. So let's break this down a little bit because the approach that we're taking with the one-way analysis of variance is very different than the z or t-test worlds that we were in before. So in the numerator we have the variance due to group differences. This is what we really care about. Right? We're looking at differences between more than two groups typically, so we want to know, are there significant differences between any of those groups? Does the averages, for example, of whatever you're looking at vary significantly between one group and the next? That's what we want to know. Now, we have to control for something, though. We have to divide by something to see if whatever differences between groups we're seeing are really meaningful. And that's where we get this sort of little not really helpful term here, but variance due to random chance. Now, this is what we're controlling for, and I'm going to break that down a little bit. So let me start to translate what you're seeing here to get us closer and closer to the actual formula for the F ratio. So the numerator hasn't changed much, the variance between groups, but in the denominator we have the variance within groups. Now imagine if you're a researcher who's interested in looking at whether there are significant differences between many groups, you don't really care about whether there are differences within a single group, right? Different individuals might differ from each other who are all of the same group, for example, and some people might be interested in that, but you don't care about that. For our purposes in this study where we're interested in between group differences, the within group differences we're going to simply call error or random chance differences that we don't care about. Differences among individuals within single groups. So this is how we control or sort of look at whether the between group differences are really meaningful. So here's how you can interpret the F ratio overall. The variance between groups, which is our numerator, will be small if there are no treatment effects, if there are no differences between groups, leading to a small F statistic and therefore a non-significant p-value. Now, the variance between groups will be large if there are treatment effects or if there are differences between groups, leading to a large F statistic and a significant p-value. The p-value, of course, coming typically from a statistical software. So here's the actual formula, really the first formula in a series of formulas that build on one another. But here's the formula for the F ratio. And as you'll see, this is going to actually be the final step when we're doing the problem, which we'll get to in a little bit. So we have MS between over MS within, two terms you probably haven't seen before. So let me give some context here. MS refers to the mean sum of squares. We learned a little bit about sums of squares in the past. This is a little different than what we calculated, for example, when doing sample variance or sample standard deviation. This is a little bit of a different sum of squares, and it's also a mean sum of squares. It's an average sum of squares between groups. And this is how we measure the variance between groups. And then in the denominator, we have the mean sum of squares within groups, which is how we measure the variance within groups. So we're just translating what we saw in words on the previous slides to an actual formula we can compute. But as I said, all these formulas have formulas of their own. So MS between is calculated by dividing SS between, your sum of squares between, by DF between, your degrees of freedom between. So mean sum of squares is literally a mean sum of squares. Think about what a mean is. You take a sum, you add up some stuff, and you divide by how many. Well, that's kind of what we're doing here, but it's sort of a very different look on the surface. But that's what we're sort of inspired by. So the mean sum of squares is the sum of squares divided by how many, which is degrees of freedom. So we have, for between and within, very similar formulas here. MS between equals SS between divided by degrees of freedom between. For MS within, we have SS within divided by degrees of freedom within. And all four of those terms, SS between and within, degrees of freedom between and within, have their own formulas. Again, this is why it gets a little bit overwhelming. Let's start with the easy part, the degrees of freedom. This should typically take you 20 or 30 seconds to figure out. On the left here, the degrees of freedom between equals k minus 1, where k is simply the number of groups, or levels of your factor if you want to get technical with the terminology. So if you're analyzing in this one-way analysis of variance differences between three different groups, k equals 3. So your degrees of freedom between would be 3 minus 1, or 2. Again, it takes just a few seconds. Degrees of freedom within is just as easy. NT here stands for N total, your total sample size among all groups in your entire study, minus K, the number of groups. So if we had, say, 30 people in our study and there were 3 groups, your degrees of freedom within would be 30 minus 3, or 27. So that's the easy part of the problem. Let's get to the hard part, the sums of squares. This is where 95% of the work is. If you can calculate sums of squares, which is what I'm going to really focus on and teach you the steps for, the rest of the problem takes about 2 minutes and it's really easy. So you can see just on the surface, it's a little bit more complicated. We're even seeing things we probably haven't seen before, at least in this video series. For example, we have sigma sigma. We've seen sigmas many times before, but we've never seen sigma sigma. And so that's something I'm going to help you, again, through steps, figure out how to calculate. I would really recommend not just trying to go straight for these formulae. You're just going to get wrong answers. Follow the steps because some of these things like sigma sigma are not really too obvious how you would get straight to. All right, so let's get down to business. The steps for calculating these sums of squares. Now here's the general structure of how these problems work. We're going to start by calculating some statistics within each group. So just for group 1, we're going to find a couple statistics. And then just for group 2, some statistics. And then just for group 3, or for however many groups you have, just those groups individually. And then once we have those within group statistics, then we'll do the across group stuff, the between groups stuff. So for the first part of these problems, the within group stuff, here's all the values you need. First of all, you need the sample size within that group. Notice this is not N total, this is just N. So you'll end up with N1, N2, N3, however many groups you have, sample sizes for each group. Then you'll have sigma x, which means the sum of all the values in that group. So again, you're going to have one of these terms for every single group. The sum of the values of group 1, the sum of the values of group 2, and the sum of the values for group 3. This third term actually isn't necessary to find f, but it's a really helpful term just to find in general for interpretation purposes, as I'll kind of describe here. So x bar is your mean, so the mean of group 1, and then the mean of group 2, and then the mean of group 3, or for however many groups you have. This, again, doesn't go into any of the formulas I've shown you so far, but it's really helpful to figure out, if there are differences, where differences are coming from. So let's say, for example, the group 1 mean is 7, and the group 2 mean is 7, and the group 3 mean is 84. Okay, so then it's pretty obvious from looking at these means that group 3 is driving the differences here, is driving your significant result. So I always recommend looking at the means, but again, if you just want to get the F test statistic, you can skip this step altogether. Okay, second of all, or fourth of all, I don't know where I got second. Then you take, for each group, again, we're within each group. We already have n, we already have sigma x. You take those two values and you compute this. You take that sigma x you calculated here, you square it, and you divide by the number of people in that group. And again, you'll have one of these terms for every single group. And then you have the sum of the squared values within each group. So this is why I always recommend when you're calculating a one-way analysis of variance, one of your very first steps should be squaring all of the values. Creating 3 new columns, if you have 3 regular columns, 3 groups of data, create 3 new columns that are just squared versions of each of your original columns of data. And again, I'll illustrate through a sample problem very soon. Okay, so once you have these values within each group, then it's time to do the across group stuff, which again, everything builds on what comes before it, and the same is true here. So the first thing you need to find is NT. Well, this is pretty simple, right? If you have the N for each group, the sample size for each group, to find the total sample size across all groups, you're just going to add up all those sample sizes within each group. This is also where we get sigma sigma x, right? We already have all the sigma x's for each group. So to find sigma sigma x, we're going to add up all the sigma x's. So the sum of each group's values, and then the sum of each group's values, right? So just to visualize this, imagine you have a sum of the values for group 1 plus a sum of the values for group 2 plus a sum of the values for group 3. That's where you get sigma sigma x. Next, you're going to see here, this term looks ugly, but look, it's just the things we already calculated before it. So we already have sigma sigma x. This is one value, by the way. We're no longer, in the world where you have a value for every single group. We added all the group values into one single value. So we already have sigma sigma x. We're going to square it, and then we're going to divide by the total sample size. And then we have two terms left. So to get all of this term here, so sigma x squared over n, we're going to add up the sigma x squared over n's for each group. And finally, you might be noticing a theme. In order to get sigma x squared, we're going to add up all of the sigma x squareds. So we're going to take each group's value here, and we're going to add them up into one big value. Now notice these three terms. So visualize these three terms, take a mental note, these last three terms that we got. These are the three terms that get plugged into the formula for the sums of squares between and within. So following these steps naturally leads you to the three terms you need for the SS formula. By the way, it's three terms if I haven't mentioned already, because this term is repeated twice. It's once in the sums of squares between and once in the sums of squares within formulas. So I would take a screenshot of this slide. I'll also post a link to a PDF guide that has all of these formulas and how to use them in the description of this video, but I would make a note of all these formulas because you're not going to want to memorize these. There's too many, right? But what I will mention here is that these formulas build on themselves, where you're typically going to start at the very end, and then you're going to work your way up. So the F ratio is going to be your very last little, division to do, right? You're not going to start with this top formula. You're going to start with the degrees of freedom and then the sums of squares. And then you're going to use those two things to get the MS, and then you're going to use those two things to get the F, right? So again, once you've found some of these terms like the sums of squares, all that is very easy and quick. You just have to get used to it. But let's do a practice problem to illustrate. All right. So here you can see I have a bunch of data. I've already gotten us started a little bit. You can see, for example, I have three different groups. I have data for group 1, data for group 2, and data for group 3. And I've also squared each of those groups' values. So here's group 1 squared, group 2 squared, and group 3 squared. So for example, this first person here in group 1 got a 6 on whatever we're talking about, right? And then their squared value is 36. The first person in group 2 got an 8, and their squared value is 64. And the first person in group 3 got a 9, and their squared value is 81. And then what I would recommend is just creating 3 sections on your page where you're going to list all the statistics within each group, because there's going to be a lot of statistics floating around, and you really want to keep them separate. Just label everything, use subscripts as I will. I think that really helps just keep everything straight, and that's what we're going to do here. So first of all, let's start with the within group statistics. So the first thing we needed to find was the sample size for each group. So N1, the sample size for group 1 equals 8. We have 8 people here, right? 1, 2, 3, 4, 5, 6, 7, and 8. For N2, we also have 8 people. And for N3, we have, you guessed it, 8 people. Okay. Now, you can also look at the means. I'm just going to go ahead and do that now because, again, I think it's kind of useful. So you can see for group 1, the mean, if you were to actually calculate this out, is 5.625. For group 2, the mean is Again, I'm keeping subscripts straight here. I think that's really helpful. 6.625. And for group 3, x bar sub 3 equals 8.125. So already it looks like we have some between group differences, right? Group 3 seems to be higher than group 2 by quite a bit, and group 2 seems to be a little bit higher on whatever dimension we're looking at than group 1. And so the analysis of variance is going to ask whether some of those differences might be significant or not. Okay, so we already have the sample size. The next thing in that list of steps I gave you that we'll need to find is the sum of each group's values. Now I'm looking first of all at just sigma x. We will soon have to find sigma x squared as well, but that's again another story. So for group 1, if you were to add up 6 plus 6 plus 5 plus 8 plus 7 plus 6 plus 3 plus 4, sigma x would give you 45. If you were to do the same thing, add up all the values, the regular x values, not the squared values yet, in group 2, 8 plus 7 plus 6 plus so on, you would get 53. And finally, the sum of the values in the third group, if you were to add up 9 plus 8 plus 9 plus 9, would be 65. All right, we have a couple more terms to find within each group, and then we can get to the between group differences. So we need to find sigma x sub 1 squared over n1. Now this is just taking 45 squared over 8. And if you do this, again, it's just the two terms we already have, you're going to get 253.125. Okay, we're going to do the same thing for group 2 here, sigma x 2 squared over the sample size for group 2. We're going to get, again, 53 squared over 8, and this term here will come out to be 351.125. One more here, sigma x 3 squared over the sample size for group 3 is going to be 65 squared over 8. See, the math is pretty simple and it all builds on what came before it, as I've been saying a few times, but it's really just about following the steps. 528.125, that's your last term here. So we only have one more thing we need to find within each group before we start adding up stuff across groups. We need to find the sum of the squared values for each group. So we have sigma x squared for group 1. Notice the squared is within the parentheses, which tells you it's the sum of the squared x values, equals, if you were to add up 36 plus 36 plus 25 plus 64 plus 49, and so on, you would get 271. Now let's add up all the squared values for group 2. So sigma x squared for group 2 equals 359. This is just adding 64 and 49 and 36 and so on. And last but not least, sigma x squared for group 3. 537. All right, now we get to the good stuff. Now we can start adding up to get those final terms across groups. So the first term we need across groups is n total, n sub t. Now that we already have the n's for each group, n sub t is very easy to find. It's just the sample size of group 1 plus the sample size of group 2 plus the sample size of group 3, 8 plus 8 plus 8, which comes out to 24. Next, we have that term sigma x, which again probably looked foreign in the beginning, but now you should kind of have a guess of how we find that. We already have the sigma x for group 1, sigma x for group 2, and sigma x for group 3. So to find sigma x overall across groups, we're going to add those three terms up. So 45 plus 53 plus 65, which comes out to 163. So now all that's left is to find those three key terms that gets plugged into the sums of squares formulas, which then gets plugged into the mean sum of squares formulas, which then gets plugged into the F ratio. I told you there's a lot of formulas, but hopefully you see that this math is actually pretty easy, and it's really just a matter of practicing it over and over again. So the first key term is going to be sigma x squared over n total. Well, this should be pretty easy, right? We already have sigma sigma x, and we already have n total. So to find sigma sigma x squared over n total, we're going to do 163 squared over 24. And this is going to come out to our first key term. Let me clean that up a little bit. Our first key term of 1,107.04. The 4s aren't cooperating here. There we go. All right. So next we have just two more things. We have the sigma, the sum of sigma x squared over n. So look here, we already have sigma x squared over n for each group. Here's sigma x squared over n for group 1, sigma x squared over n for group 2, and sigma x squared over n for group 3. So to find sigma x squared over n, we're just going to add those three terms up. So 253.125 plus 351.125 plus, sorry, I'm getting a little small here. I just want to make sure we have enough room for the rest of the problem, plus 528.125. This gets us our second key term for the formula for the sums of squares, 1,132.38. All right, last term, you can hopefully kind of guess how to get this one based on everything we've learned so far. So sigma sigma x squared means we're going to find, we've already found, the sigma x squared for each group. So to find sigma sigma x squared, we're going to add up each of those values. So sigma x squared for group 1, 271, plus sigma x squared for group 2, 359, plus sigma x for group 3, 537, which gets us our last term, 1,167. Okay, now we have the degrees of freedom, which again should be pretty quick, and then we'll just be plugging in for the rest of our lives here, right? So we have degrees of freedom between, I'm just going to put b instead of between to save some time here, which equals k minus 1. Try and remember, what does k equal? The number of groups, right? We have 3 different groups. So k minus 1 is 3 minus 1, which is 2. And the degrees of freedom within is going to equal nt minus k. Our total sample size we already have, right? It's 24 minus the number of groups, which is 3, is going to equal 21. Now we can plug into our sums of squares formulae, right? You might want to look back at your notes to see, or I guess not necessarily your notes, but maybe either the PDF I have linked below, or maybe scroll back in the slides here a little bit to see those formulae for these sums of squares between and within, because I'm not going to rewrite them. But for sums of squares between, we're going to plug in this first term here, 1132.38, which is what we found right over here, minus 1107.04, which gets us 25.34, and SS within equals 1167. Again, this term right here, I'm just pulling these terms and literally just plugging them into the different parts of the formulas. 1167 minus 1132.38, which gets us to 34.62. All right, sigh of relief at this point in time because we have 99% of the work done. We just have a couple formulas to plug into, and then we're done. Notice we already have sum of squares between and degrees of freedom between, sum of squares within, and degrees of freedom within. So to find MS between, we're going to take our SS between divided by degrees of freedom between. Now again, it's not really a lot of extra math. We're just taking values we already have and dividing them. So for MS between, we're going to have 25.34 divided by 2, which comes out to 12.67. And for MS within, we have SS within divided by degrees of freedom within, which comes out to 34.62 divided by 21, or 1.64. Congratulations, you're down to your last formula here. So here we have F equals MS between over MS within, which comes out to 12.67 divided by 1.64. And your F-test statistic is 7.70. You're done. This is it. That is the test statistic, or the F ratio, for the one-way analysis of variance. Now I'll note that you can also calculate the effect size for a one-way analysis of variance. It's very simple to do once you already have all your terms. It's simply taking your sums of squares between, SS between, divided by SS total, which is just between plus within, and that's going to get you a measure of effect size called eta squared. You can look that up if you'd like some more information. I just want to briefly mention it because note we already have SS between, and we already have SS between and within, which we can add together to find the total. So if you want to calculate the effect size, it's pretty simple to do, and it just takes a few seconds. So that's how you calculate the one-way analysis of variance and the effect size for the one-way analysis of variance.